Yes. All right. Welcome, everyone. Glad so many of you could be here to hear me talk about dependency injection. Woo. I'm going to share with you some experience we've had building customer-specific internet offices with a single code base. Our main goal was to keep the code reusable. And I think we've managed that quite well, and we learned quite a lot by that experience. I thought I'd share a bit with you about that. But first of all, this is me. My name is Henrik Ygge. I'm the CTO and co-founder of a small IT company here in Stockholm called Meepo AB. We're actually right across the water here. If you go out into the main hall and look across the water, you can see us in Mariehissen. I've been a professional Java programmer since 2008. In my job, I've tried various different other programming languages in various consulting roles, but I always end up coming back to Java, so I guess that's where I'm meant to be. I don't use social media, but if you want to get in touch with me for any reason, please do. You can reach me at henrik@meepo.se. So, what is this talk about? We recently built a project with a lot of customer-specific logic against a common back-office system, and we tried to keep the code reusable, and we did that by modularizing and using dependency injection a lot. And that's basically what I want to share with you, how we ended up structuring the code and what we learned in doing it. So, the agenda, some background. What have we built and why? What is dependency injection? How we ended up structuring our code. How we use dependency injection to achieve maximum code reusability. And a short summary at the end. All right, so let's start. We got involved in a project where several insurance companies use the same standard back-office system, but they needed a simple end-user portal to be able to show basic insurance information. And this is life and pension insurance information for their end users. And we wanted to maximize the reusability, and we wanted to simplify, since the life and pension industry is quite regulated and lots of complicated data models everywhere. We wanted to simplify it and only show the customers or the end users what they really need to see. Not too much and not too little. So what did the users want to do? They wanted to be able to see their insurances, see how much money they have, what will they probably get out when they retire, how much money has accumulated during this time. They might want to be able to change their funds depending on some different rules. There might be documents that they could download, like insurance policies, for example, if they do a change. And when they get closer to retiring, they might want to say, where do they want the money? And do they want it now, or do they plan on working more and therefore want to postpone it? And there are lots of integrations that were needed for this. We needed to integrate with the back office system. We needed an integration with Bank ID to be able to log in. We need an integration with Morningstar, which is a standard system for handling fund data. Like what's the sustainability, the risk, the basic information about the funds, yield over time, etc. We needed a database, and more than one database because of different requirements. There were different databases for different customers and different environments. We needed to integrate with an AD provider, LDAP, to be able to see if an employee at the insurance company wants to log in for support reasons or to be able to do something. We need to be able to verify that they can actually log in as well. And there were insurance company-specific systems. For example, if not everything had been migrated, or there was information that they wanted to be able to see together with their insurance information, but that wasn't available in the back office system. So, just a quick word on the front end. That's not my expertise, but I thought I'd include it. We built a single-page application in Vue. And the idea there was to keep the views and the texts customers specific, so they can design their views in any way they want. They can have their own text, they can have their own styling, their own colors, everything. But that the components that they used should be as generic as possible. So the table of which insurances they had, or the fund tables, etc. We wanted to be able to reuse them. But let's move on to the fun part, the back end. This is a Java conference, right? So we built it in Java 17 and Spring Boot. And lots of use of dependency injection and modules. So that's what I want to get back to. So when we designed this, we thought, which part of our system can we keep generic and which part has to be more customer specific? So when we visualized it, this is what it looked like. We needed a client that communicates with an API. The API calls some logic and some mappings to gather all the data it needs and feed it to the API. And the logic and the services need to communicate with different systems to gather the data it needs. So which parts do we need to keep customer specific and which parts can we try to keep generic? And the idea was that the client probably needs to be customer specific. We really need to be able to let them choose their own styling, their own text, probably their own views. But the API can probably be customer specific, or sorry, it can be generic. We can use the same API for all customers, but might be with some small tweaks, but we'll cross that bridge when we get there. Let's start by designing a generic API. And the logic as well, that's more a handling of how does the data look in the different systems and what are we mapping it to. Let's try to keep that generic as well. And the integrations are, of course, integration specific. If we want to communicate with Bank ID, that doesn't care which customer we use it for. It's the same API. So we can, if we have that in a separate module, all the customers that want to use Bank ID can just include that module. All right. So what is dependency injection? I thought I'd just talk a little bit about that before we get into the architecture. This is one of the first lines on Wikipedia I found about dependency injection, but I think it's really good. It's a form of inversion of control. Dependency injection aims to separate the concerns of constructing objects and using them, leading to loosely coupled objects. So the main takeaway there for me is that the code that uses an object or an interface doesn't need to know how it's implemented. It should only care about, there is some way for me to perform an action. How that action is performed, I don't really need to care about. And the loosely coupled programs is also important, that you can keep it modularized. You don't have to have direct dependencies. So in Java, dependency injection is used by interfaces. You define interfaces that have actions. Either you can get information or you can update information. This is actions that is possible to do on this interface. And then you have components which implement these interfaces or these actions. And when you reference this, you only reference the interfaces. This way, there are no hard dependencies on the components that do the actual implementation. Let me know if I'm going too quickly. So an example. Let's say we have an interface that gives us the detail about a fund. So the interface is simply one method, given a string ID, give me details about the fund. And then we have a controller that says that I don't really care how you give me the details about the fund. I just want to know that there is a way for me to fetch these details. So when the getter here is called through the REST API with an ID, we simply hand it off to the interface. Just give me the details about this fund. Someone else handle how it's done. I just wanted the information. And then you can have multiple implementations. For example, you can have a Morningstar implementation that says, when we want this fund data, go to Morningstar. They know all about these funds. Give it to me. Or you can have some sort of other service. In this case, I just created a dummy internal fund service. It could be some other backend system, or it could be some other way of fetching the data. But these can, the main point is that the controller doesn't need to know which one of these it's using. It just needs to know that there is a way for me to do this. All right. A note about injecting dependencies. Since you saw here that, the controller here, can you see the mouse? Yes. The controller here only knows that it needs to be able to have this, this interface implemented. But how that's done, it doesn't really care about. So for Spring Boot or Spring to be able to fetch this, it needs several things. It needs that the component that we're injecting needs to be annotated as a component. There are various subclasses of this. A controller is a component. A service is a component. There are lots of different implementations of this. And it needs to be under dependency injection control. If you create your own instance of something, dependency injection will not see it and inject these dependencies. And then there are 3 ways, maybe more, but 3 ways that we've used of identifying for dependency injection framework that this interface needs to be implemented. The easiest is to just use autowired. You annotate an instance variable with autowired, and this makes, when the service is instantiated, Spring Boot will automatically fill it in with an implementation that matches. The downside of this is that for testing, you can't reach this from the outside. So for testing, you probably need a setter anyway. And if you have a setter, you can annotate the setter instead. This works as well. What we ended up using is the 3rd way, which is the constructor. I really like this way, primarily because you can actually mark your interfaces as final. It's always good to know that it's not possible at runtime to change the implementation if you're not sure you really want it to be able to be changed. So I like this. It's also helpful in your tests that if you add a new dependency or a new interface, either you have to add it, if you add it to the constructor, or you need to add it to the constructor to be able to have it injected. And then if you have tests that use this, you will get a compiler there that this is not implemented. If you use the setters, you have to remember to add it. But you will probably see it when the test fails, but it's good to catch them as early as possible. The downside of this is if you have lots of interfaces for a service, the constructors can be quite big. You can have several constructors as long as you mark one of them as the autowired, but we've ended up using one, and then you don't need any annotations on those. So that's more of a style choice, whichever you want to use. They all work. I prefer the constructor way. So when I've discussed this with colleagues and things, it's quite abstract. Everything is just interfaces everywhere, and you don't really know how they are being used. So one way to visualize this is as a graph that, okay, we want to add this API endpoint or this API module. What does that infer? It means that we need to have some way of implementing these interfaces that they reference. Some ways of doing it, probably we need to add some more modules that implement them. Maybe we already have them then we're fine. But we need to be able to make sure that these are already these are available at runtime. And these might have more interfaces in their turn. So you need to be able to make sure that at startup there are implementations available for all the interfaces that you're using. Probably in real life, you won't start by adding an API. There's probably a customer demand that says, we want information from Morningstar, we want information from this system, or we want this extra information. So you start in the other direction and add all the way to the API. But I usually find that it's easier to start with the API when you think about it, because that is the main entry point for the calls. And they are not referenced by anything else. All right. So how did we end up structuring the backend? We used Java modules, and lots of them. So we separated all of our components into different modules. This meant that when we built this project for a specific customer, only the needed modules were included. So we could have several modules that implemented the same interface, but we only included the one that the customer wanted to use. And this also meant that a change of implementation is simply a change of the import. Let's not use our old fun data. We want to use Morningstar. We switch the implementation and it's done. That's really powerful. And it has worked really well. So the way we ended up structuring it is we have a service module that basically contains all the interfaces and all the modules that we needed. In this case, we had it in a single module just to be able to decrease the number of modules in our system. You can, of course, split this up into multiple modules if you need to, but we found that it was enough to have it in one, just to get, just so we could visualize it easier. And then we had the API modules, and this was more of a, how can I put this? This was something that evolved. We started out with quite few modules with several different endpoints in them, and once we realized which endpoints are actually belong together, we split them up into multiple. So in the first iteration, we had one endpoint, or one module that contained probably all endpoints, and then we realized some customers don't want these, let's split them out into a separate module. So this was more of a evolving method of splitting it up as it was needed. And then we had the integration modules, and here we have separate modules per integration. I'll get back to that they are plural there, but it was actually quite good to have split an integration into several modules as well for testing, but I'll get back to that. So if you visualize the dependencies, hope this is visual, yes. You can see that, for example, the API on the left side and the integrations on the right, all of them just reference the services. There are no direct dependencies between any of the other modules, just so that we can switch them out at runtime or at build time. And the database as well only reference the services. In this case, we have several database implementations, SQL and Swift, which is a distributed database that we needed for hosting in the cloud. But then, this is how it looks at compile time for our modules. We then added the customer modules. These contain the container, these build the containers to deploy. So for a customer, it contains which modules and which properties does this customer actually use, which endpoints are they using, and which implementations are they using to fulfill these endpoints. And there could be customer-specific configurations as well. So when you look at a customer's module dependency, it looks more like this. It has a reference to the services, but it also has a reference to specific modules that they need in the API endpoints and specific integrations that fulfill these endpoints. And one of the databases that it needs. So the integrations and the services and the APIs don't really need to care which database are you using. There's just an interface that says, I can save and I can retrieve this data, then whichever database is currently included in the build will be the one that handles it. And the properties for the customer will depend on which module is chosen as well. Yeah, so how can we be more specific about which modules should implement which interfaces? We could use property control injections. This is a way of saying that we can include multiple implementations in the build, but which one is actually used is controlled by a property in runtime. This was really helpful for example, the database again. We wanted to produce one build that is possible to deploy in several different environments, but that use different databases. And then you can produce one build, deploy it to several different environments, and just control with a property which one is actually used. And this is used with the conditional on property annotation. So in this case, if the database.implementation property is set to H2, we will use this database implementation. Or if it's missing, that's what the match if missing does. If this is not matched, this service will just not be seen by Spring Boot. So it's just ignored. So none of its dependencies needs to be fulfilled or anything. Yeah, this was really helpful in the cases where we wanted to be able to switch this without doing new builds. You can have default implementations. There are cases where you have a standard case. This is the way we want the system to work, but for some reason or another, one customer wants it in a different way, or there's some way that you want to have a specific implementation in one case, but in the main case, you want a standard way. And this can be done with the conditional on missing bean. So this class says that I know how to create this transaction setting interface. If there's no other way of doing it, let me know and I'll give you one. But if you find another one, I'll just be quiet and don't ask me. So in this case, for example, with the transactions, it could be that we have a standard way of handling all the transactions. But if you want, some customer wants a different way of doing it, we can implement a specific version for them and include them in their build. And as long as it finds that component, it will be injected instead. There is also possible to inject multiple implementations. So instead of injecting an interface, you can inject a list of an interface. And this Spring Boot will then find all the implementations that fulfill it and add them to this list. And if there are none, it will not fail. So it will simply give you none. And this can be helpful. I have an example here with authentication. It could be that you have several different ways to authenticate the user. We talked about bank ID. There could be the LDAP choice or single sign-on case. So in this case, you create an interface that says, given this request, is this user authenticated? And if it is, what are the user details? So in the filter then, you can simply say, given these, the list of these handlers, loop over them and tell me if one of them finds an authenticated user. And if they do, we want to know about it. So if you don't include any authentication handlers here, none will be authenticated, but if you have include multiple, it will use the first one that's available. Another thing that's real, qualified, sorry. If you want to include multiple, you can say, for in this case, I want this interface to be to use a specific implementation. We have not really used this much, but I thought it would be amiss to not include it, because when you have multiple implementations in your project, IntelliJ will complain and say, you need to qualify this because I don't know which one to use. But that's sort of the point. We want to have multiple and decide it in build time instead. But it's possible to qualify it. So in this case, you can say that in this specific service, we always want to use this implementation, regardless of any other structure that is given for any other interface or implementation. Another fun thing you can do is you can inject objects. You don't need to inject interfaces. And this can be really helpful if you want to share data across the app. Like when the request comes in, you want to fulfill some data. There's some person ID, there's some information about the logged in user, for example, that you want to set on an object and be able to retrieve elsewhere in the app without having to send it through all the different calls. And that's set up by a scope annotation. So the scope, what it does is it says that in this case, we want the session info class, or an object of session info. Yes. And we can set the scope here to say that we want this to be by request. So if a request comes in, it will get a new instance of this that you can set data and get data from, and other requests won't see it, but the same request will see it further down in the call chain. And this is achieved by the proxy mode here. So you can say that this class is really a proxy. So the class is still there. You can inject it in the same way. You get the class that you can mark as final. But as soon as you try and get or set things from it, it will actually use attributes on the request in the background. Which is really handy for sending data around, or just making sure that the request data is kept within the request. Yes. Another thing that I want to talk about is automated testing. This works really well with dependency injection. First, you can use dependency injection to make sure that what you are using actually works. Since it's quite a lot to keep in your head, do we have all the implementations we need? How does the interfaces look? You need to verify the setup. And since Spring Boot fails on startup, if you don't have all your implementations ready, or if there are multiple ones, for example, you can just simply test it by creating a Spring Boot test that verifies that the application starts. This will use the build configurations and the properties and everything. And if there is something that causes this build to not work, the test will fail. Which is really, really helpful. And since it's quite a lot to keep in your head, and if you add new endpoints or you change implementations, to verify that it doesn't break for other customers. Another way you can use the tests is that dependency injection really helps in testing. So it's really easy to mock dependencies, and you choose the boundaries yourself. So if you want to, when you unit test a component and you have the dependency injection interfaces everywhere, in the test you simply add your dummy implementations, or the implementations that do whatever you want it to do, to fulfill that that interface. You can also test the components together with the rest of the app. So you can start up an app and use all the logic, for example, from an integration for mapping the data, but not actually use fetching data from that integration. So when I previously said that we have multiple modules for a single integration, that was because of this. So, for example, with Bank ID or Morningstar, you can have the logic for mapping all the data in a module and then have separate modules for actually fetching it. And that means that you can substitute so that you fetch the data from a file or from some other place, but still use the logic for mapping it. And you can choose how long your tests, the boundaries of your tests, really. Yes?
May I ask a question?
Yeah, sure, go ahead.
Yeah. When you refer to modules,
Yeah.
something I don't fully understand is if those modules are conceptual modules or they are physical in the code base. And then did you have access to all the modules at one time? Or you were somehow picking them via Maven? Or what do you mean exactly?
The modules are really Java modules, separate Java modules that don't have any direct dependency. They are included in the same physical or same code base, the same project. So all modules are available at compile time, but they are not depending on each other. And when you build for a specific customer, you let in the build script, you say which other modules are depending on this module, or which other modules do I want to include. So you can have a huge Java project with lots of different modules structured in different ways, but they are not automatically depending on each other. They are only included if you include them in the build file.
So at one time you have only the modules you actually want?
Yes, exactly. So in the compile time, you have, or the project has access to all of the modules, and you can see all of them, but they don't reference each other. So you just include them in the final build and say these are the ones I want to include. But yes, we used real Java modules that built their own jar files. So there are lots of different jar files, and all of them have references to one other, basically. And then at build time, we just puzzle them together. Yeah. And then, of course, you can have end-to-end tests where you actually start up your application and you go all the way to the different endpoint, the real services, and make sure that they still work as well. So there are various ways of testing this that work really, really well, but you can specify what you want injected in the different parts. I noticed that I might have been talked a bit quick because I'm nearing the end of my talk already. But I'll just go through a quick summary, or a summary of what I want to take with you from this. The modules are really a key thing here. Try to keep your code base in different modules and break it up into smaller parts. If you do that, it will be much easier to not have hard dependencies between the different modules. And this will also mean that you will probably find which parts of your code are possible to split and which aren't. But the ones that are really would benefit from having different modules. Testing as well. We started out by having some basic tests for this, but it's really helped to be able to load up your application as in the unit test phase and really see that all of them are actually connected. It's quite difficult if you have lots of modules to visualize them in your head and know that all of them work together. And yeah, try to keep logic as general as possible. Try and have the default cases or the way you want the system to work in one way. And then if there are extra things that a customer wants or needs or has access to, then those can be specific implementations and modules on the side. But try not to keep them in the general logic. Try to keep them on the outside. Yes, customer-specific logic can be injected. And there are lots and lots of different ways to control and configure dependency injection. As soon as we had a problem where we found this is something that would be good to be able to do, we could Google and find, oh, Spring Boot has already thought of this. This is excellent. We have what we need. There are probably lots and lots of more ways than I've talked about here, but these are the ones that we've used that has actually worked really well for us. Yeah, that was basically what I had. Any questions?
Yes.
Yes, go ahead.
About the modules.
Yes.
Java modules.
Yeah.
I mean, okay, there has been some time since they came now, but
Yeah.
in the beginning, all the third-party libraries and Maven Central, etc., was not modularized, and you make a module and you can't access anything.
Mm-hmm. Yeah.
Is that situation gone now?
Well, it depends a bit. I think it's gotten much better. We haven't really run into a lot of those problems. I mean, the parts that you want to be able to access, they really need to expose them so that you know that they are available. But I know what you talk, because when we started working on this, we really wanted, some modules were not available to be able to inject it in this way. But I think it's the last, yeah, now it's better. I think it's getting better, yes. And I mean, this was Java 9. So even if the release cycle is much, much higher now, it's still a couple of years ago. So I think most frameworks have caught up now. Yes?
How do you structure your project? I'm assuming you're using Maven or something like that.
We're actually using Gradle.
Okay.
Yeah, but same thing.
You have some modules for each customer,
Yes.
and that includes all the different modules.
Yeah, the way I did a bit of a simplified version here where there were, I only added a few modules just to make it easier to visualize it. But the way we ended up with, basically we had an API module, and then under that we had all the different API modules as submodules to that. Yeah, exactly. So I think on the top level there were only like the API, the integration, some integration testing, and the customers, and then everything else was stored under that in some sort of structure. And I think IntelliJ really helps a lot there, that you can hide the ones you're not interested in, and you can have dependencies, like if you have a general API module and then submodules to that. If you want to have generic API code, like validation or things, you can keep that in the general API module that is then referenced from all the other ones. So you can build a hierarchy of dependencies there, but that's mainly to avoid duplicating code. Yes, go ahead again. Yeah.
Have you ever considered breaking out each module to an own Git repo and publishing the jar file indexes or something like that, so you can just reference that? So each customer will get their own Git repository. Instead of having a huge code base with like everything,
Mm-hmm.
you split it up in separate modules. Like Maven Central works, you can just pick and choose. You can use comments and Guava and just put in everything you need for that specific customer.
We thought about that. It hasn't gotten that big that it's a real problem for us yet to have everything in the same code base. And I think it's actually kind of nice so far that it works that way. I really like the idea of having everything in a single Git repository, so that if you do changes that affect multiple things, you can do it in the same merge request. But that's a discussion that I know has been happening. Should you have one giant Git repo, or should you split it up so you can do actual releases in them, for example? So far, we've used a single. Yes. Mm. Yeah. So far, I'm still on a single module is quite, or a single repository is really nice. But there are problems with it, as you say. One of them is that the build time might be quite large or just checking out the project and starting a new one could take some time. There's also building. If you change something or you switch a branch, it could be that then you have to switch the branch for the entire project, and if there are changes, you will have to rebuild the entire project. But I still think so far for us, it hasn't been a problem that it's a single Git repository. Yes, go ahead.
Regarding testing,
Yes.
if the final product
Mm-hmm.
application is a combination of different modules,
Mm-hmm.
what case did you test? How did you manage to test different combinations of stuff? Talking about integration testing.
Yeah, good question. So we tested it on several different levels. We have customer-specific tests that test flows that we know the customer uses with as much real data as possible for that customer. But if we have, for example, a service for mapping fund data from Morningstar, for example, then that doesn't really depend on the customer. We can test that component in isolation. How are we mapping these funds, as long as we have some data from Morningstar to assist us? So if you keep that in, for example, a JSON file that looks like the data that comes from Morningstar, we can inject that data or inject an implementation that uses that into our service and verify that given that Morningstar produces this data for us, how does our fund detail class, for example, look like? So we can test that in isolation, but it's also good to be able to test the whole flow. So we've ended up with unit tests, of course, for all the different modules. We also have component tests that more test the generic component, but not in a customer-specific way. And then we have customer-specific tests that tests more flows through the system with as much real dependencies as possible. And those are usually their own modules with their own build files and their own properties that resemble how the customer uses it. We also have what we call live tests, where we actually use the customer's build files, or we reference the module for the customer, start up their version, and then do tests. But there since everything is live, we don't have that many tests of it, since they only work if everything is online and we can have an exact copy of their database. Yes?
I think this is a more practical question, but with modules and the component scan.
Mm-hmm.
So essentially when you're developing, if you have a single repository, you will have everything available.
Mm-hmm. Yeah.
So how do you say, oh, we don't want to run this module right now? So how can we practically do that? It's more of an IntelliJ stuff, so okay, we want to run it. So how do you prevent the Spring Boot component scan from picking up these modules?
But do you really need them to not be, when what we ended up doing was basically to have lots of suppressions for when we injected the interfaces, that IntelliJ can't really help us with what actual implementations are being injected, since there are multiple versions of most of the interfaces we have. But at runtime, or when we test something, there we always know which one it is, and then we only include the ones we need. So besides the component scanning, I think that IntelliJ does in the background and gives you help with what is missing, or which one it suggests.
But is that before you actually build the customer-specific version?
That's when you look in IntelliJ and see, because it tries to give you some assistance with which interface, which implementation are we actually going to inject in this interface. But then when we build it, since there is no dependency on the actual thing that we are that's going to run, the implementation, it will only build the code that is referenced. So it doesn't really care that which interface is going to be implemented at runtime. It will only build what is needed to make sure that the interface works regardless of how it's implemented.
Yes, but say that you have a customer that has a bug.
Sorry, a customer.
The customer has a bug and you know they don't use this module.
Yeah.
And you believe it is because they don't use
Okay. No, when you run it in IntelliJ, you can start the Spring Boot container as one of the application routes for a customer. And then it will only include the ones you have. So you can recreate the exact customer-specific configuration in runtime as well in your development environment. So you don't have to do an actual physical build and deploy it somewhere. You can test customer-specific things in your development environment. Anything else? All right. Thank you very much for your time.